Hello everyone, my name is Varsha Chaudhary. I am from IT department. Today I am going to present sorting algorithms in data structure. Searching algorithms are used for search a particular element from an array or a list, and sorting algorithms are refers to the operation of arranging data in some given sequence from array or list of elements, such as increasing or decreasing order. We can rearrange our array or list of element in the form of increasing and decreasing order for performing sorting operations. There are some types of sorting algorithms. First is bubble sort, selection sort, insertion sort, quick sort, heap sort, merge sort, radix or bucket sort. Today I'm going to explain bubble sort. What is bubble sort and how bubble sort works, and what is the algorithm for the bubble sort. So bubble sort is a simple sorting algorithm. This sorting algorithm is comparison based algorithm in which each pair of adjacent element is compared and elements are swapped if they are not in order. This algorithm is not suitable for large data sets as its average and worst case complexities are 0 and 2, where n are number of items. So how bubble sort works? In these algorithm, traverse from left and compare adjacent elements, and the higher one is placed at right side. In this way, the largest element is moved to the rightmost end at first. This process is then continued to find the second largest and place it, and so on until the data is sorted. Let's take an example for understand the working of bubble sort. To understand the working of bubble sort algorithm, let's take an unsorted array. The elements of array are, we are having an array who has have 5 elements such as 13, 32, 26, 35 and 10. Now we are going to apply bubble sort on these elements or on these array. We start bubble sort from first pass. In first pass, sorting will start from the initial two elements. Initial two elements that are 13 and 32. Let's compare them to check which is greater. We have to compare 13 and 32 to check which number is greater. Here 32 is greater than 13, so it is already sorted. Our 32 is greater number and 13 is smaller number. That's why we don't need to swap elements because these are already in increasing order. Now we are going on comparing to second elements. Second elements are 32 and 26. Now we compare 32 with 26. Here 26 is smaller than 36, so swapping is required. As we see, 26 is smaller element and 32 is bigger element or greater element. That's why we need to swap elements. After swapping, a new array will look like. New array will look like 13, 26, 32, 35 and 10. You can see the differences between both array before swapping and after swapping. Now, same process will repeat for next element. Now we have to compare 32 and 35. Here 35 is greater than 32. As we see, 32 is smaller element and 35 is greater element. So there is no swapping required as they are already sorted. Now we are going to other next element. Now the comparison will be between 35 and 10. Our last two elements are going to compare 35 and 10. Here 10 is smaller than 35 and they are not sorted. So swapping is required. Now we reach at the end of the array. After the first part, the array will be. We are comparing 10 and 35, and as we see 10 is a smaller element and 35 is bigger element. So there is need of swapping. We need to swap 10 with 35. We have to rearrange 10 on the place of 35 and 35 on the place of 10. So this is so place these two numbers on different places is called swapping. Now we reach at the end of array. Our all elements of array are visited at the first pass, and the array will look like 13, 26, 32, 10 and 35. Now move to the second iteration. We have to move second iteration. Our first pass is completed. Now for second pass, second iteration, we have to move. The same process will be followed for the second iteration. We repeat same process which we have followed in first iteration or first pass. Same process will repeat for second pass. Now we start second pass. First we have to compare 13, 26, two elements of our array. First two elements of our array are 13 and 26. Now we have to compare 13 and 26. As we see, 13 is smaller number and 26 is bigger number. So there is no need of swapping because they are already in sorted order. Now we are going for other element. Our other element for comparison is 26 and 32. Now as we see, 26 is smaller and 32 is greater number. So again no swapping required. We have to go for third step. In third step we have to compare two elements. Our two elements are 32 and 10. So as we see, 10 is a smaller element and 32 is bigger element. So we swap 32 with 10. We place 32 on the place of 10 and 10 on the place of 32. After the swapping, our array looks like 13, 26, 10, 32 and 35. Now we are going for other step. In our array's last elements are 32 and 35. So we have to compare 32 and 35, and as we see 32 is already smaller number and 35 is greater number, so there is no swapping required. Now our second iteration will be completed here and we have to move for third iteration. Third iteration or third pass. In the third iteration or third pass, the same process will be followed for the third iteration. First, we have to compare first two elements. First two elements are 13 and 26. As we see, 13 is smaller and 26 is bigger. So no need of swapping. Our array is as it is as previous. Now we are going for compare next two elements. Our next two elements are 26 and 10. Now we see then 10 is smaller and 26 is larger. So we have to swap both numbers. We have to swap 26 and 10. We have to put 10 on the place of 26 and 26 on the place of 10. So after the swapping, our sorted array will be 13, 10, 26, 32 and 35. Now we are going for next step. As we compared first three element, after that we have to go for fourth element. Now we compare third and fourth element. As we see, third element is 26 and fourth element is 32. So 26 and 32 already in sorted order because 26 is smaller than 32. So no need of swapping is required. Now we are going for comparing next elements. Our next elements are 32 and 35. As we see, 32 is smaller than 35 and our array is already in sorted order, so there is no need of swapping. Now we are going to move for fourth iteration or fourth pass. Our third pass is completed here and we are going to compare elements in the fourth iteration or fourth pass. In the fourth pass, similarly, after the fourth iteration, the array will be 13, 10, 26, 32 and 35. Here 10 is smaller than 13, so swapping is required. After swapping, the array will be 10, 13, 26, 32 and 35. Why swapping is required here? Because 10 is the smallest number and 13 is greater number. So as our requirements, we are arranging our array in the decreasing order. So we need to swap the elements. We have to swap 13 and 10. We can put the value of 10 on the place of 13 and the value of 13 on the place of 10. These processes now completed and our array is sorted now. Now our array will be in decreasing order: 10, 13, 26, 32 and 35. Hence there is no swapping required. So array is completely sorted. Now we have to discuss about the complexity. All the processes and algorithms have complexities. Two types of complexities are here: time complexity and space complexity. Now let's see the time complexity of bubble sort in the best case, average case and worst case. We will also see the space complexity of bubble sort. First we have to discuss about the time complexity with three cases: best case, average case and worst case. Time complexity of bubble sort with the best case is 0n. Time complexity of bubble sort with the average case is 0n to the power 2, and time complexity of bubble sort with worst case is 0n to the power 2. Now what is the best case, average case and worst case? So best case complexity, it occurs when there is no sorting required, that is the array is already sorted. The best case complexity of bubble sort is 0n. Average case complexity, it occurs when the array elements are in jumbled order, that is not properly ascending and not properly descending. They are in between ascending and descending. The average case time complexity of bubble sort is 0n to the power 2. Now worst case complexity, it occurs when the array elements are required to be sorted in reverse order. That means suppose you have to sort the array elements in ascending order but its elements are in descending order. The worst case time complexity of bubble sort is 0n to the power 2. Now we have to discuss about space complexity. So space complexity of bubble sort is 0, 1. It is stable? Yes, it is stable. The space complexity of bubble sort is 0, 1. It is because in bubble sort an extra variable is required for swapping. The space complexity of optimized bubble sort is 0, 2. It is because two extra variables are required in optimized bubble sort. Now we have to discuss about advantages and disadvantages of bubble sort. So we have some advantages of bubble sort. Now the advantages are: first one is bubble sort is one of the easiest algorithm. It is very easiest as compared to other algorithm. It is easy to implement. The algorithm is also easy to implement as compared to other sorting algorithms. Elements are swapped in place, not use extra array. We can swap elements on similar array. We do not have an extra array for swapping process. We swap elements on the same array. It is stable and fast. It is a stable process and it is very fast. Now we are having some disadvantages of bubble sort. So disadvantages are: it does not deal well with a list containing a huge number of elements. It is not suitable for large number of data sets or large number of elements. The code become complex for large amount of data. The code become complex for large amount of data, more than the number of comparisons. That means it is not suitable for the large amount of data, and The code of this algorithm is complex as the number of data is varies. If the number of data is varies, we are going to become complex code. So it is not suitable for large amount of data.